Chinese rocket is on its way to the moon with a mission to bring back rock samples back down to Earth.
The space race has reluctantly accepted a third competitor, China. Even though the US and Russia have a head start in the fight for supremacy in space, China is obliterating any doubt as to its prowess with a series of shocking discoveries. The latest is the terrifying new discovery on the moon by China, which changes everything we thought we knew about the satellite. Stay tuned as we bring you all the details in this video. When many people think of the moon, they hardly think about water. However, a new discovery by China may finally show the presence and origin of water on the moon. According to scientists, the moon's formation was a turbulent process full of cataclysmic events and collisions on an astronomical scale that eventually led to the creation of our closest celestial neighbor. And this celestial story is not only captivating but also gives us crucial insights into the early solar system and the formation of our own planet, Earth. Around 4.5 billion years ago, during the Hadean era, the entire solar system was a tumultuous place. Planets, protoplanets, and other celestial bodies were engaged in a chaotic dance, resulting in many collisions. Earth, still in the early stages of formation, was not exempt from these violent interactions, and the moon's genesis story begins with one such cosmic collision. According to the leading theory known as the giant impact hypothesis, a Mars-sized celestial body dubbed Theia struck Earth in a glancing blow. The sheer force of this impact was unimaginable enough to vaporize Theia and eject a significant portion of Earth's mantle into space. This event also set Earth spinning at a much higher rate than today and could be responsible for the axial tilt our planet currently has. The colossal collision's aftermath resulted in a ring of molten rock, dust, and debris orbiting the young Earth. The materials consisted of remnants from both Earth and the obliterated Theia, heated to extremely high temperatures from the energy of the impact. This debris ring was the raw material from which the moon would eventually form. According to the China National Space Administration, it is the moon's youngest terrain. The Chang'e 5 probe from China landed near Mount Rumka, a 43-mile-long or 50-kilometer mountain rising about a mile above the horizon. China's Chang'e 5 lunar lander is a crucial part of China's daring sample return mission, and the spacecraft recently made a historic discovery. It became the first spacecraft to detect water on the moon at its landing site in real time. Chang'e 5 found water at its landing site near Oceanus Procellarum on the moon's near side, using an instrument that detects water by determining spectral reflectance measurements of regolith or soil and rocks. Astronauts could use the water that is already present on the moon. This could make it easier to establish a permanent base on the moon and could also serve as a stepping stone for further exploration of the solar system. In addition to its practical uses, water on the moon could also have important scientific implications. The presence of water on the moon could provide clues about the history and evolution of the solar system. By studying the water on the moon, scientists could learn more about how water is distributed throughout the solar system and how it may have played a role in the development of life. The discovery of water on the moon also opens up new possibilities for international cooperation in space exploration. Countries and space agencies could work together to establish a permanent base on the moon using the water that is present there to support their operations. And this could lead to new scientific discoveries and technological advancements, as well as foster greater cooperation and understanding between nations. Now, there is another fascinating discovery by China on the moon made by the Yutu-2 rover, the first spacecraft to explore the surface of the moon's far side. The rover landed in Von Karman crater atop the Chang'e 4 lander and has been working its way northwest during each 14.5 Earth Day-long lunar days ever since, using its 4 science payloads to image and analyze its surroundings as it goes. Yutu-2 is a lunar rover that's part of China's Chang'e 4 mission. The rover landed on the far side of the moon in January 2019 and has been exploring the lunar surface ever since. U-2 is equipped with a variety of scientific instruments that allow it to analyze its surroundings and make discoveries. These instruments include a panoramic camera, a lunar penetrating radar, a visible and near-infrared imaging spectrometer, and an infrared imaging spectrometer. The rover is powered by solar panels, which provide energy for its operations during the lunar day. During the lunar night, when temperatures can drop to minus 180 degrees Celsius, minus 292 degrees Fahrenheit, the rover goes into hibernation mode to conserve energy. The mission will also need the help of a relay satellite beyond the moon to communicate with Earth, as the far side of the moon never faces Earth due to tidal locking. The Chang'e 6 mission is part of China's ambitious lunar exploration program, which aims to facilitate a crewed lunar landing in the 2030s and possibly build an outpost near the lunar South Pole. The mission will also contribute to the scientific understanding of the moon and its formation and evolution. The Chang'e program is being carried out by the China National Space Administration and aims to achieve a number of milestones in lunar exploration, including orbiting, landing, and returning samples from the moon. The program is divided into several phases, with each phase building on the achievements of the previous one. The first phase involves sending orbiters to the moon, which was achieved with the successful launches of Chang'e 1 in 2007 and Chang'e 2 in 2010. The second phase involved landing and roving on the moon, which was achieved with the successful landing of Chang'e 3 in 2013 and its rover U-2. The third phase involved collecting lunar samples and returning them to Earth, which was achieved with the successful launch of Chang'e 5 in 2020. And the fourth phase involves establishing a robotic research station near the moon's south pole.